fire. Pretty cool stuff, right? But just what is fire? And why can I hold this fire in my hand? Okay, so it's a pretty safe bet to say you all know what fire is. You know, that hot flickering light you get whenever you burn something. But just what is fire made of? And what makes fire? To answer these questions, let's start out by asking ourselves, what exactly is fire? Now, as you might imagine, fire is the result of a chemical reaction. In particular, this chemical reaction is known as combustion. Now, combustion is a chemical reaction between two substances, a fuel and an oxidizer. Combustion reactions result in the release of a great deal of energy. You can see this really well in a hot air balloon, where by simply lighting the burners, you fill the envelope with hot air, which lets the hot air balloon rise up in the sky. If you want an example that's a little closer to home, we have the burning of coal, which produces the majority of the electricity in the United States, allowing you to turn on the lights and, indeed, watch this video. There's also the burning of natural gas, which heats many homes, probably yours as well. And also the burning of gasoline, which allows most of us to travel by bus, by car, to wherever we're going. Combustion reactions belong to a family of reactions known as redox reactions or oxidation-reduction reactions. An oxidation-reduction reaction, or redox reaction, is a type of chemical reaction that involves the transfer of electrons between two species, with species in this case meaning the different forms of elements. Okay, so in every one of these redox reactions, they can be broken down into two parts, the reduction half and the oxidation half. One species is losing electrons and the other species is gaining them. To remember which one does which, just remember oil rig. Oxidation, it loses. Reduction, it gains. In the case of combustion, our two components are the fuel and the oxidizer. Combustion usually occurs when a hydrocarbon reacts with oxygen to produce carbon dioxide and water. Hydrocarbons include a wide range of substances. We have gases like ethane, methane, and propane. We have liquids like octane and benzene. We even have solids like paraffin wax. For today, we'll be looking at the hydrocarbon butane. Butane is the easily liquefied gas that's used in gas-type lighters and butane torches. Butane contains 4 carbons and 10 hydrogens. When we combust the butane, we end up with a reaction that looks something like this. Now, this is in fact a redox reaction. So, what is being oxidized and what is being reduced? The oxidizing agent in this equation is the oxygen, and so it is the oxygen that is being reduced, while the butane is being oxidized. But wait, this equation isn't balanced! We all know we can't create or destroy matter, so we need equivalent numbers of each element's atoms on each side. So let's start out by counting out exactly how many atoms of each element we have on the reactant side and the product side. Okay, so now that we've counted out all the atoms, we can start to think about how we're going to approach balancing this equation. Now, as you may recall, when balancing chemical equations, we cannot change the components of the equation. We can only change how much of these components there are. In our case, our components are butane, oxygen gas, water, and carbon dioxide. Now we can see that oxygen gas, though it's diatomic, is only composed of one element, oxygen. And on top of that, the oxygen gas is the only component on the reactant side containing oxygen. This allows us to manipulate the oxygen on the reactant side without affecting the quantity of any other element on the reactant side. This means we should leave it off until last. Okay, let's start with the carbon. We have 4 carbon on the left and only 1 on the right. All the carbon on the right is bound up in carbon dioxide. So to end up with the same number of carbon on the right as the left, we need 4 carbon dioxide. This does give us a balance of 4 carbons on each side. However, we must also keep in mind that we now have 9 oxygens on the product side as well. Next up to balance is the hydrogen. We have 10 hydrogen on the reactant side and only 2 on the product side. All the hydrogen on the product side is bound up in H2O, water. To match the 10 hydrogen on the reactant sides, we need to multiply that water by 5, so that we also have 10 hydrogen on the product side. This also means we now have 13 oxygen on the product side as well. Now we have both the hydrogen and the carbon balanced for this equation. All that's left is to balance the oxygen. We have 2 on the reactant side and 13 on the product side? 13 isn't divisible by 2. How do we solve this problem? Well, we make it divisible by 2. Multiply the entire equation by 2, and you'll have a number for the oxygen that's divisible by 2, 26. All we have to do now is multiply the O2 by 13 to get a balanced 26 oxygen on each side of the equation. And that leaves us with a balanced chemical equation. 2 butane molecules will react with 13 oxygen molecules to produce 10 molecules of water and 8 molecules of carbon dioxide. Hydrocarbons aren't the only chemicals to undergo combustion reactions. There's alcohol, acetone, even orange peels. What would it look like if you burned, say, pure hydrogen? What about pure carbon? Can you think of a way something could combust without oxygen, hydrogen, or carbon being present? Until next time, keep exploring, keep learning, and keep thinking.